examples here in just a minute. So if we take a look at the first one right here, square root of 3 over square root of 5, and if we would like to simplify that, we can, the easiest way to do this one is to take the denominator and multiply it by the square root of 5. But if we multiply the denominator by the square root of 5, we have to multiply the numerator by square root of 5. So there's our one that we're multiplying by. This would then give us the square root of 15 all over the square root of 25. Ding, 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 ding. And then the denominator, the square root of 25 is 5. So we can rewrite this as square root of 15 all over 5. That is completely simplified. Now we have to check the square root of 15. Is the square root of 15 okay? Yes, because it has no perfect square factors other than 1. Okay? Square root of 6 over the square root of 8. There are two ways that we could go about doing this problem. And this is where, oops, we okay? I can zoom in there a little bit. You're welcome. There's a couple of ways that we can do this. Let me show you, first of all, if we use the rule. If we use the rule and take the square root of 6 all over the square root of 8 and multiply this by the square root of 8 all over the square root of 8, then that will give us the square root of 48 all over the square root of 64. And the square root of 64 in the denominator we know to be 8, so then this would be the square root of 48 all over 8. But square root of 48 is not simplified. So now we're back to rule number 1. And we have to find perfect square factors of 48, one of which would be 16. 16. So then we have to write this as the square root of 16 times 3 all over 8. And then take the square root of 6. Oh. Yeah, I don't know if it keeps recording if the screen goes blank or not. We'll find that out. Or Kendall will find that. Okay, there we go. So the square root of 16 then would be 4 root 3, all of that over 8. And then we've got 4 over 8, and 4 over 8, we can write that as the square root of 3 over 2, because 4 divided by 8 gives us a half. That's one way to do it. There's an easier way to do it. If we look at this and say 6/8, if I would write that as a fraction under the same radical, 6/8, I can simplify that fraction. Because 6/8 simplified is 3/4. And then I can write this as the square root of 3 all over the square root of 4, which would be square root of 3 over 2. We end up with the same answer. It's just that one requires more work and more steps. This is one of the reasons that people take longer on tests. Is some people will follow this procedure and some people will follow this procedure. You'll end up at the same place, but this one might take twice as long as this one. It depends on what you see in the problem. With that in mind, let's take a look at the next one, square root of 12/18. Would somebody care to propose a way for us to simplify square root of 12/18? Go to option 2. Option 2 to put it under radical, and let's write this as 12/18 and then simplify that. 12/18 simplified would be? Well, if we go this route right here and simplify the fraction first. I'm sorry, that's what I thought you were suggesting. Okay, so then we could write this as the square root of 2/3. Yeah, now smaller numbers are usually easier to work with. And then we could write this as the square root of 2 over the square root of 3. And get rid of the root 3 in the denominator, we would multiply by root 3 over root 3. Which would be root 6 over root 9. And root 9 we know to be 3, so this would be root 6 over 3. Now, yes, Shannon?
We don't want the root in the denominator.
You don't want the root in the denominator. Exactly. That's what we're doing. The formal, yeah, go ahead.
I just want to make sure that was the goal.
Yep. The formal mathematical term is we are rationalizing the denominator. Well, okay, because here we have a root in the denominator. Irrational numbers in the denominator are messy for division. So if we rationalize the denominator and get that's what the 3 is a rational number. Okay, I'd like you to do the next one, square root of 15 over the square root of 27. You can do whatever method you would like to simplify that. And we have root 5 over 3, okay? And we're getting there. You got it. Woo-hoo.
I did?
That's right.
Oh, okay.
Yeah.
You could stop thinking?
What?
You could stop thinking then?
Well, not stop thinking. You can stop working on that problem, but never stop thinking. Interesting. The different approaches people took. All right, so I'm going to borrow Daylene's. And I'll borrow Maggie's. What's that?
What I did. Were you asking me that?
Yeah, if we look at these two procedures, if we take a look at Maggie's way here, you went ahead and multiplied, just like we did over here, the first method was multiply top and bottom by root 27. And you get some big numbers here. You get root 405 over 27 in the denominator. Then you've got to break down the 405, and you end up at 5 root 3. Okay? As opposed to the Daylene method. And the Daylene method over here put them both under the same radical and simplified the fraction first. When you simplify, oh, that's nice because we end up with a perfect square in the denominator. This was the Shannon method also. If you simplify it first, square root of 9 we know to be 3, so we end up with 5 root 3. And you end up at the same place. It's just a different number of steps. All right. With that in mind, what I would like you to do is go back to our trig ratios, please. If we go back to our trig ratios, and I believe this was the one that we were working on, a number of those are in need of putting up. We did the first condition, but we didn't take care of the second condition. So if we look at sine of A right here, and I've got an awful lot crammed onto the page, but if we look at this 3 over root 13, we need to pretty that up, so we'd have to multiply this by root 13 over root 13, and we see this as 3 root 13 over 13. And that would be the preferred way for this to look like. And what I'd like you to do is I'd like you to go through and pretty up the rest of them using this second principle of simplifying radicals. Anna, do you have all those? Maggie?
Mm-hmm.
All right. Second column was pretty easy. There's only one or two of them that had to be fixed up as well. Shannon, how are you doing?
Going.
You're going? All right. And ladies and gentlemen, that's where we're going to draw things to a close. Okay? These are the types of things that you will see a couple of questions on the final, reviewing this, where there might be some questions where I simply ask you to simplify them. Or you may also need to simplify them in a context, where you kill multiple birds with one stone, if you will. Okay, but a question would be something like this. If I gave you problems like these before we started, I could give you a problem like this and say, find the sine of A and the cosine. I wouldn't find you to find the cosine of B, because the sine of A and the cosine of B are going to be the same thing. But I could ask you to find the sine of A and the sine of B, and that's going to get you through this whole process that we've just been talking about today. All right, I'm going to stop the video a second. Oh my goodness, that's a half an hour video. How long is that?